Okay, so let's talk about terminology and properties that you have to using a microscope. So we've got working distance, field of view, focal plane, clarity, parfocal, parcentral. So let's talk working distance. Working distance is the distance between the bottom of my objective and the top of my slide. So if you look, there's the bottom of my objective. This is the top of my slide. When you bring an object into focus, that working distance usually decreases. So now it's not here, it's up here. Okay? Now, watch. As I increase magnification, because this is my 4x objective right here, when I go to the 10x, look at that distance between the bottom of my objective and the top of my slide. I can't even fit my finger in there anymore. So as you increase magnification, that working distance actually gets a lot smaller. So I'm going to just put this back in focus real quick. And then I'm going to switch to 40x. That looks like it's practically touching the top of the slide, right? As you increase magnification, you're getting closer and closer. That working distance shrinks, okay? So this is one of the primary reasons why when we are looking for a specimen, we start always with the smallest objective. The smallest objective is the one that has the greatest distance from our slide. So even if I were to take the stage and jam it up toward the top, there is still no chance of this hitting the slide, breaking my slide, or the slide breaking my objective. So you start at the bottom, always, okay? And you work your way, while looking, of course, up until you find what you're looking for. You find whatever specimen that you're looking for. That is the way that you are supposed to do that. Okay. Now, if I've got it in focus, one of the, I guess, caveats, one of the things that they say is if you have it in focus at the lowest objective, you should be able to switch the objectives and it should stay in focus. If you have an object centered at the lowest objective, then you should be able to switch and it'll stay centered. Parfocal and parcentral are that concept. Does it work that way? No. That would be in a perfect world with unicorns and rainbows, which we do not have. So when I switch to the 10x, remember what I said about that distance getting so much, where is it? That distance getting so much smaller, I will never touch the course adjustment again. I will only use the fine focus because although it may not be perfect, did you see how much I moved that? I don't need to move it very much for it to be in focus. If I move to 40x, the next objective higher, again, only fine focus. I can move it just a little bit and it'll come back into focus. I don't have to start all over from scratch. That's parfocal. Now, parcentral, I'm going to put something specific in the middle of my field of view. When I switch, it should be centered. Now, again, perfect world, unicorns and rainbows. Is it? No. So what do? These knobs right here actually move my specimen left to right and front to back. So I can adjust the position. Did I have to move it a lot? No. I didn't because technically I'm supposed to be centered. Now, again, in a perfect world, I would be. Not in a perfect world. So I'm going to switch to 40. Is it centered? Actually, it is pretty centered. So I'm just going to leave it. But those two terms, that's what we're talking about. Okay? So The field of view. This is what you are actually seeing in the microscope. So I don't know if this is going to work without me having to fiddle with something, but I'm going to try and show you. The field of view. So the field of view is what you can actually see in the scope, what the area that you are actually visualizing. Okay? So this would be your field of view. If I were to go back down to 4x, you'll notice that the objects are now a lot smaller because I have increased the distance from them. Okay? As I zoom in, the amount of space I'm seeing is actually getting smaller. So when we talk about the field of view, as magnification increases, the field of view actually narrows. So if I were to outline where this is relative to this, it would be smaller. And it would be smaller because I'm zooming in to the object that I'm looking at. So the amount of space gets smaller. Just like if I were zooming into somebody in Central Park, I wouldn't be able to see the rest of the park. It would just be the person I'm looking at. So what I am actually looking at has gotten smaller, even though what I am looking at has gotten bigger. I hope that makes sense. Okay. Oh, so that's field of view. The focal plane. As we increase magnification, our focal plane decreases. So what do I mean by focal plane? I'm sure everybody here has seen a movie where they go through a building with the camera and you go through, let's say, the fifth floor first, and you can see the people up here, and then you go through the floor of the fifth floor till you come out the ceiling of the fourth floor, and then you see the people on the fourth floor. That plane, okay, that depth, because it's also called depth of field, you can see that with a microscope. Okay, so you will see the different levels depending on where that microscope is focused. The higher the magnification, the less depth of focus you have. In other words, instead of maybe going floor to floor, we're going foot by foot. The higher the magnification, the more kind of planes you have. Okay, the more levels you have. The classic example of this is the silk threads slide. You have a red thread, a blue thread, and a yellow thread. Okay. And as you focus the scope, you will see each one individually. So here's that classic three silk string slide. You'll notice that at 4x, pretty much everybody's in focus. But when you turn up the magnification, okay, I'm going to move this slightly. You'll start to notice that that clarity isn't there. And if I move, each string will eventually come into focus. If I can make it work, because my camera wants to fix it. So there the blue is in focus. You can see the details. But as I keep going, the red comes into focus. Okay? Because I'm literally like slicing a ham going through the layers. So that is the focal plane. Okay, this is a little bit better of an example. As I focus down, you can see the red threads very, very clearly. Now, the next to come into focus would be the blue threads. You can see that the red have kind of gone out of focus a little bit, and the yellow looks like it's kind of coming into focus. Well, as that blue thread loses its focus, you can actually see the detail of the yellow thread because it is red on top of blue on top of yellow as you go down. Okay, I just wanted to show you that. Clarity is kind of like resolution. We want to have a clear image that appears. You can increase magnification all you want, but if there's no clarity, you can't see your sample, which isn't helpful. And we just went through parfocal and parcentral, but give me 1 second. So here is our blue thread, technically centered and in focus at 4x. When I move to 10x, it's not necessarily in focus anymore, but I don't have to, hang on. I don't have to move it very much for it to come back into focus. It also isn't centered, but, sorry, if I use the little dialy things on my stage to move my stage around, I can move it back to center with very little movement. And again, it's not necessarily perfectly in focus, but it doesn't take much. I don't have to go back using the coarse adjustment to get it to where I want it to be. There's very little movement and poof, I've got it where I want it. So parfocal, parcentral. Okay, so when you are using a microscope, you technically have two lenses that are magnifying. Yes, you have the objective down here that is magnifying based on whatever that number is, so 10x, 4x, 40x, etc. But these oculars also magnify. Standard is 10x, 10 times what your naked eye can see. So you're seeing an image that is 4 times bigger, magnified by 10 times. So you've got two magnifications happening. This is one of the reasons why we call it a compound microscope, because you're compounding the magnification effect. Okay? So if I were to ask you for the final magnification, let's say that this objective is 40x, and like I said, this ocular is 10x. What's the final magnification that you see? Well, you would multiply these numbers together, 10x times 40x. So what's 10 times 40? 400. So your final magnification would be 400x. Do not forget your units. Units are really important. Now, let's change this. Let's say that this is 4x and 10x objective. So 4x times 10x equals 40. So it would be 40 times greater. Okay, it would be 40 times what you can see with your natural eye. And when you're calculating magnification, literally all you have to do is multiply whatever the magnification of the objective is times the magnification of your ocular, and you get the final result, the final magnification. Okay, oops. All right. Microscopes are expensive. The one that I'm using here is probably between $5,000 and $10,000. So they have to be treated with respect, because unless you have $5,000 or $10,000 that you can afford to buy the school a new one, you have to treat this again with respect. So how do you handle it? Well, one thing is you always use two hands when you're carrying it. One on the arm, one underneath the base. That way you have a good grip on it. You never ever want to uh, try and like hold it just by this or hold it in one hand. That's not a good idea. They're heavy, they're kind of awkward weight wise, they don't really distribute their weight very well. So you want two hands to ensure that you've got a good grip on the microscope. Okay. Now, oil immersion. Remember, I said that the 100x objective is only used in certain situations. So oil immersion is only used with the 100x objective. The 100x objective is sealed so that when you put oil down, it will not go up into the objective. If you use oil with the 40 or the 10 or the 4, you're going to ruin the objective, okay? Because they are not built sealed so that oil can't get under them. You always work your way up. You center with 4x and put it in focus, go up to 10x. Again, center and focus, go up to 40x, center and focus. And then once you're there, okay, you are going to, so for the sake of argument, we're going to say that there's a slide here. And I got all the way to 40 and boom, it's in focus. Remember how close 40 was to the slide. You are going to half turn this, okay? Half turn this between the 40 and the 100. You're going to put a drop of immersion oil, dead center where you see the light coming through, and then you're going to slide your 100x into place. Now, when the 100x goes into place, it's going to hit the slide. That's one of the reasons why the oil is there. It actually helps it to kind of glide across without breaking the slide or breaking the objective. There's also a spring because it is going to actually touch the slide. Okay. So the 100x never gets used unless there's oil. And you have to work your way up to that 100x as far as focusing and everything else. Before you move your stage, flip the nose piece between the objectives. Like I said, you're going to kind of do that half thing. Okay. So let's say I'm finished. I'm done. I've finished with my slide. You're going to rotate the 100x out of the way and put 4x there. Remember I said that no matter what I do, I'm not going to hit anything with the 4x in place, even with the course adjustment. With the 100x in place, there's a real good chance I will. So if I move it, there's no chance I'm hitting this on anything, no matter which direction I move the stage, up, down, sideways, whatever. Okay? So you're going to take your slide off. You're going to move your objective. You're going to take your slide off. You're going to move the stage down. Now is the time that you get alcohol. You clean the objective with a Kim wipe and alcohol, and you clean the slide off with a Kim wipe and alcohol, because water will just not do anything with oil. Okay? So that's how we clean after we're done. Once you're completed, you will use lens paper and alcohol, like I said, to clean both the objective and the slide. Now, most of the time when we're doing slides in micro, we don't have cover slips. We don't have anything like that. So it's a little bit more challenging because once you use oil immersion, there really isn't a good way to clean your slide off. So that is the lecture on the microscope for the lab.